Okay, what we're going to talk about now is rational exponents. All it is changing from one form to another. This right here is called radical form. And now what we're turning it into is exponential form. Meaning the numbers from the radical move up as just a power, a fractional power. There are a couple ways to write it. This is the most common, but you can also write it that way. And then don't forget, when you have a negative power, you have to move it to the other side. So jump the line, change the sign. And then everything becomes a positive. So technically the step in between here was 1 over a to the positive m over n. And then they converted it into that. All right, let's see some. So 8 to the 2/3, you're going to write a radical, put the 8 on the inside, and then put the bottom number on the shelf, and the top number becomes the power. And that's it. You could also write this with the cubed root, and inside is 8 to the second power. So either one, they mean the same thing. Okay, 24 to the 1/2, that's going to be 24 inside a radical. Now 2 on the outside, that's standard, so we actually don't have to write it. Oops, I was going to write it again. And then that 1 that goes on the inside, right here, that one usually isn't written either. So this one's just going to stay and look like that. This 1/2 power right here is always equal to the square root. Square root of a number. Okay, next one. This one says the cubed root of 18. All right, now we're going to go to a fractional power. So you write 18 in parentheses. Now this 3, if you remember, it came from the numerator. And then to find the denominator, you look on the power of the inside stuff, which, you know, it's not written, so we assume it to be a 1, which means 1/3 goes on, or sorry, 1 goes on top of the fraction. Okay, this one, 2 in parentheses, because that's the base inside. And then you've got 5 and 6. Inside goes on top, outside goes on bottom. Okay, let's practice. Rewrite in exponential form. So exponential form is where you're going to have a fractional exponent. Or no, I'm sorry. Exponential form, yes. So this is a fraction in the power. Sorry about that. All right, let's see, we've got 10 was the base. The outside number was 5. And the inside number was 10. Sorry, 1. Okay, this one right here, same thing. Put 100 in parentheses. The bottom number, the bottom number is the number outside, which is technically 2. And the top number is 7. Done. All right, this one, -8. Now the whole thing has to go in there, inside, including the negative. Now the outside goes on top, the inside goes, or sorry, the shelf, the number on the shelf goes on bottom, the power goes on top. So sometimes it's not outside, sometimes it's inside, just depends on what place it is. Okay, so we've got our N and our M, number outside, and our number inside. So we put our radicand, the stuff inside, and it's going to be 7/6. Okay, this one, step inside is 2x, include everything that's on the inside. Now the number on the shelf we know is 2. There's no powers anywhere, so you can think of this whole thing as to the 1. So these guys go to the 1/2 power. Okay, -3x is what's on the inside. We've got 2 numbers. One's on the shelf, that's always on the bottom. And on top is the other number, so it'd be 3/4. Okay, this is just y. I don't need parentheses. You can put them, it's not wrong. Inside or the power goes on top. The shelf number goes on bottom. So power on top, shelf on bottom. Oops, forgot none. Oops, oops, oops. Shelf on the bottom. All right, so this part right here, 18x, the number's here 2, so power goes on top, index goes on bottom, sorry, the number on the shelf. And then this negative sign, since it is outside, we just continue it and put it outside in front of there. Okay, so now we're given to them in exponential form, and we're going to flip them to radical form. And then we're going to simplify, and all that means is the stuff we've been breaking down, like jail. All right, so it's a radical with the base inside, and then the number outside, or sorry, the number on the bottom goes on the shelf, and then the top number becomes the power. Then it says to simplify, so we're going to start inside, square root of 9, 3 and 3, we need a pair of homies. 1 makes it out, so that's just 3. And then don't forget your power that's up here, because that's part of the answer as well. So 3 to the 3rd, that's 27. Okay, 125 to the 1/3, that's going to be 125 inside a radical, don't need parentheses. So start with the radical, 125, bottom number goes on the shelf. Whoops, gosh, how many times have I said whoops so far? Somebody should keep a count. 125 was in time. This bottom guy is on the shelf. Denominator on the shelf, numerator goes as a power outside. We don't really need that one, so I'm just going to go to simplifying. Okay, we're looking for the cube root. 5 times 5 times 5, that's 3. How many make it out? Only 1. Everybody else dies. Okay, this one says 32x to the 3/5, so I'm going to make a radical. Put 32x inside. Bottom number goes on the shelf. Top number goes outside. All right. Let's simplify this inside here. So 2 is 5 2s. No, we've got our x. So 5th root, 1, 2, 3, 4, 5, x. Okay, we're looking for groups of 5. Looks like I got a group of 5 right here. Right, homies, let's go. Only one makes it out, the other ones die. And then unfortunately the x doesn't have any homies, so he's just got to stay in there. So this rewriting them as a fractional power into radicals is nothing new from what you've been doing for days now. The only decision you have to make is, do I put the 3 outside a set of parentheses, or do I put it inside on the actual value? Okay, this one has a negative power. Uh-oh, negative power. That means jump the line. And that's to change your power. So it comes 1 over x. Now it's to the positive 3/5. Okay, applying my rule, this on the bottom becomes the 5th root of x to the 3rd. I put that third, the numerator, on the inside so that you can see that it's done either way. Okay, this is only 3 x's. I need a power of 5, so that's going to be our finished answer. Okay, 27 to the 1/2. I'm stuck in green. Means radical 27, 1 power, 2nd root, square root. Okay, oops, I don't need to write the 2. Sorry, that's around. Okay, so that's, oh, wrong problem. Hello, here I am. Glad to make your acquaintance. Okay, 27, 3 and 9, 3 and 3. So this becomes the square root of 3 times 3 times 3. Oh, look, pair of homies. One makes it out. One dies. Next one. 4x, so radical 4x, 5, and then to the 3rd power. So breaking apart this guy, there are no homies, right? But if you rewrite it as 4x to the 3rd, then you can apply some of the properties. That's the same thing as 4 to the 3rd, x to the 3rd. And this is 4 times 4 times 4. Each one of those is 2, 2. This one is 2, 2. So once you actually for real spread this out, it's going to be the 5th root, 2, 2, 2, 2, 2, 2, and then x, x, x for the 3 x's. Okay, we do have a pair of homies. Got 5 2's right there. One makes it out. And then we look at what's left inside. We've got a 2 and 3 x's, so 2x cubed.